Howdy there, Mr. Sutton here with the IM3 Honors 1-3 Extra Practice Number 3 solutions on piecewise functions. In this one we have a puzzle to solve. For this puzzle we're trying to answer the question, can y equals absolute value of x be written as a piecewise function? And to solve this we're going to be using our graphing calculator to graph out each of these piecewise functions and match them with one of these functions down below. Whenever we find the function that we're looking for, the letter that goes with that is going to go above the problem number that we just did in these boxes down below. So for example, if I do number 1 and I figure out that it's B, it definitely isn't, but let's say it were, then I would put a B in spot 1. So let's go through and see what we can figure out using that grapher. Alright, so for our first question we have the piecewise function negative x from x less than 0 and x for x greater than or equal to 0. So let me go through putting this in the graphing calculator. So here I am on my grapher. To enter this in the y equals, it's a little bit tricky. The way they showed it on the handout is you have to basically put your branch, your function, in one parentheses and multiply it by another parentheses that has the inequality in it. So for example, I would write parentheses negative x, close parentheses, and then another parentheses, and x, and I need to get less than. To get all these inequality operators, I have to go to second math, and that's going to give me my test operators here. So that's going to be less than, that's going to be option 5, so you can just press 5 for that. So less than 0, close parentheses. Now what this does is this inequality piece here, it either comes out true or false, depending on what the x value is. If it comes out true for x values less than 0, this parentheses is going to just give us back a 1, which is going to get multiplied by this piece here, and it's basically you're going to get whatever you would get if you plugged x into negative x. If this stuff over here comes out false, then what your calculator does instead is it turns that into a 0, which zeroes out this branch. So this is going to get graphed for all of infinity, but we're going to see the true graph for the parts that make this true, and the parts that make this false, it's just going to be a line that we can't see on the x-axis at y equals 0. So let's move on now and do the second branch. So we have an x, I'll put that in a parentheses, although I don't really need to, and we have x greater than or equal to 0. So second test, and greater than or equal to, that's option 4 there. So 0, close parentheses. Now when I graph this, I want to have a window that shows me something like these windows here in my answer choices. So I'm going to go to Window. I'm going to make my x values go from, it looks like negative 5 to 5 is approximately what they're using in these. And then I'm going to make my y values go from about negative 3 to positive 3. And that should be enough to show me one of those pictures. So let's graph this. And here's what I end up with. That looks like the absolute value function actually. So that's this choice L right here. So I'm going to put an L then in spot 1. Here we go now with problem number 2. Let me take a moment to enter this in my graphing calculator. So here's what all of that looks like in my y equals. Let me go to graph now. I'm going to keep the window from last time. So there's one branch. There's the other branch. It looks like an absolute value graph, just shifted 2 over. And I see that right here, choice T. So I'm going to put T in spot 2. Next up, we've got negative x and x minus 4. Let's input that in the calculator. All right, there's what I've got loaded into my calculator. Let's press graph. And now this looks like an absolute value graph shifted right 2 and down 2, which should be easy enough to spot. Yep, right there, choice E. So put that in 3. For number 4, this one is actually so simple that I'm not even going to bother using the calculator. Until we get to 0, we have a horizontal line going through y equals 1. Once we get to 0, we then have the line basically negative x plus 1, a slope of negative 1 with a y-intercept of 1. So that describes choice A. It's like right there in front of me. Here's our horizontal line. Here's our line with the slope of negative 1 and a y-intercept of 1. So A going in spot 4. For this next one, number 5, I'm going to walk us through doing this one on the grapher because it's a little trickier with this middle inequality that has the two inequalities. So let me go ahead and pull up my grapher. So here we are on the grapher. Let's see, let's put in parentheses 1, and then we have x. Let's see, we're doing test less than, so less than negative 1, close parentheses, so that's our first branch, kind of typical based on what we've seen. This next one is where it gets interesting. So I've got x squared, and then open a parentheses. Now I'm going to have to split up this inequality into two of them using an AND statement. So I can write negative 1 and then less than or equal to x. So second test, let's see, less than or equal is 6. So less than or equal to x. And to get and, I have to go back to my test menu and then arrow over to this logic menu. And I have to select and. So we've got and x less than or equal to 1. So less than or equal to 1, close parentheses. So that's kind of crazy. And then this last one is less crazy. It's just 1 and x greater than 1. Let me do graph to get all that. Hope for the best. So there's a horizontal line, a little parabola piece, and another horizontal line. And that matches up with choice U. So 5 is U. For number 6, we've got another one of these 3-rule piecewise functions. Let me set this up on my grapher. So here's what I'm entering on the grapher. We have x squared minus 1, x less than negative 1. 1 minus x squared, and then just like the question before, I'll just scroll over to show you what I did here. I used an AND statement in between these two pieces. Negative 1 less than or equal to x, and x less than or equal to 1. And then my third branch was actually just like the first one, only I had a different inequality at the end. So pressing graph for all that. Here we go. We have a piece of a parabola, another piece of an upside down parabola, and a piece of the original parabola. So let's see here. What does that look like? That looks like y. So we'll put y in spot 6. For 7, we've got another 3-pronged piecewise function. Let me put this in my grapher. Here's the setup in my y equals for my graphing calculator for this one. And press graph. There's one piece. Piece number 2 is this little horizontal line. And then piece number 3. So that is which one here? It's this little upside down drum sort of shaped one, choice B, going in spot 7. Here's question number 8. And if this looks kind of familiar, it's because the first two rules are actually exactly the same as question 7. It's just this last rule that got tweaked a little bit. So let me go to my grapher. Here's the setup in my y equals. I only had to change one little thing, making this a 2 minus x instead of x. So press graph. So there's the first two pieces, the same as number 7. And now here's the different piece. It keeps going down instead of going back up. So we've got, let's see here, kind of this sort of shape here. It looks like L. So L is 8. For number 9, you'll notice that we are back to having only 2 parts to our piecewise function, but they have complicated things a little bit because now one of those is a fraction, and we have x does not equal and x equals, which is a different sort of test than we've been using in the past. Up to now, it's been all inequalities. So let me see what this looks like on the grapher. All right, so let's walk through entering this first rule in the grapher. First off, to get a fraction, there's a couple ways to do it. You could use a parentheses around the numerator and around the denominator and just use straight up division. Or you can do alpha y equals and pull up this n over d fancy fraction mode and put x squared minus 1 there. and x minus 1. This just saves us the trouble of using parentheses. And now I'm going to multiply that, parentheses, by x does not equal 1. So we have an x, we have second test, and you'll notice there's a not equals. That's actually option 2. So x does not equal 1. Now down here I'll do 2 times x equals 1. So I need to do second test, and equals is actually the first option there. We've just been looking at it this whole time. And now let me graph this out. And interesting. This just looks like a straight line. Well, that's interesting. So I think that's going to be choice O, which is going to be 9. For number 10, this is almost exactly the same problem as number 9, but instead of having 2 right here, if we go back to 9, we've got a 1 for that second rule. Everything else is the same, though. So I'm going to go back to my graphing calculator, back into my y equals, and I'm just going to go to y2 and replace this 2 with a 1. Press graph. So there's the line piece for most of our rule. And it's kind of hard to see. In fact, can we see it at all? Yeah, so right now this looks like the last one that we graphed. But I'm going to show you something a little bit crazy here. I'm going to go to zoom, and I'm going to go z decimal. This gives me roughly the same window, but I think it cuts it a little bit more precisely with how it measures the inputs. So let me do that. So there it is. But notice now we've got a little hole in here, and there's a little dot down here where that hole kind of fell out. So that matches up with S, which is going to be our spot 10 there. And now we can actually solve the puzzle. Can y equals absolute value of x be written as a piecewise function? Absolutely, because we actually saw several of these piecewise functions that ended up being these absolute value ones. So until next time, Mr. Sutton signing off.